Advanced factoring using the GCF, or the greatest common factor. Let's start by looking at an example problem, 2x squared minus 16x plus 30. Now, your first instinct may be to do the diamond method and then the box method, because this number, right, is not a 1, and we know that if it looks like this, like a quadratic, then we have to use the box or diamond. However, before we jump to this conclusion, we must first check if there is a GCF that we can factor out, also known as, what is the biggest number that goes into 2, 16, and 30 evenly? And just a hint, this number can only be as big as the smallest number in the bunch. So in this case, the smallest number in this bunch is 2. So it can pretty much only be 1 or 2. Okay, so like I said before, it can only be 1 or 2, and we want to make sure it goes into 2, 16, and 30. And we quickly find out, well, 2 is the biggest number that goes into all of these numbers, okay? And then we're going to be using the reverse distributive property, okay? So remember, you put your parentheses, and then we want to ask ourselves, 2 times what gives us 2x squared? Well, x squared. And then we move on to 2 times what gives us negative 16x? Well, negative 8x. Okay? And lastly, we can't forget about this 30. So 2 times what gives you 30? Well, a positive 15. And then we can move on to step 2, which says, see if we can factor what is in the parentheses using the diamond or the box method. So we had 2 times x squared minus 8x plus 15. And step 2 is basically telling us, let's look at this and see if we can use either the diamond or the box. And we know for this one, we're going to use the diamond, right? Because there's a 1 in front of this x squared. So we draw our diamond. Remember, 15 goes on top, negative 8 on the bottom. We want to multiply to that top number, add to the bottom, and we find that it is negative 5 and negative 3. Okay. And then we just write it in factored form from the diamond. Now, don't forget about this 2. This 2 is still on the outside of the parentheses. So we're just going to rewrite what was inside the parentheses in factored form now. So x minus 5, x minus 3. And that is as far as we can factor. So this is our final answer. Let's try another example to get the hang of this. So again, first step, you want to look for the greatest common factor, something that goes evenly into 9, 24, and negative 9. And remember, it can only be as big as 9. So you want to think, and it looks like 3 is going to end up going into all 3 of those numbers. Okay? And then we use the reverse distributive property. So 3 times what gives you 9x squared? Well, 3 times 3x squared. 3 times what gives you this 24x? Well, 3 times 8x. And lastly, 3 times what gives you this negative 9? Well, negative 3. Are we done at this point? Not quite, because we want to look at what's new inside of the parentheses and ask ourselves if we can do box or diamond for this. And remember, you want to look at this number here to tell if we do box or diamond. And since it is not a 1, we have to do diamond and box, okay? So we're going to write our diamond down. We get a negative 9 up top, because remember, you have to take this 3 times negative 3, and then an 8 on the bottom. and it's going to be negative 1 and 9. And then we have to move to the box method. So I'm going to write that right over here. Okay. Remember, 3x squared goes in the upper left, negative 3 goes in the bottom right, and then we have negative 1x and 9x. And now we just pull out what they have in common. So 3x squared and 9x, well, they both have 3x in common. Negative 1x and negative 3, well, they're both negative and they both have a 1. 3x squared and negative 1x, they both have x in common. And 9x and negative 3, they both have 3. And at this point, we're ready to write it in factored form. So remember, this 3 right here is still on the outside, so I need to write that first, okay? So we're writing our answer over here. So it's 3 parentheses. Now we're going to take from here. So 3x minus 1, and the other parentheses is x plus 3. And that is our final answer.